Hi, I am Furkan Tunç Kocatorun, and now I will talk about our Milestone project. This is the LT-SPICE topology of our project. This is an analog RGB LED controller. It uses three operational amplifiers, as you can see, to create a color mixing effect based on a single input voltage, both in, here you can see it. As you sweep the input voltage from 0 volts to 12 volts, and it represents the potentiometer term, the LED color transitions smoothly across the spectrum from blue to green to red. Now I will talk about the pumps U1, U3, and U1, U2, and U3. These are the brains of the R circuit. They perform mathematical operations to determine how bright each LED should be at any given input voltage. Both in, it sweeps from 0 volts to 12 volts, represents the user input, and it's a potentiometer. We have voltage dividers, and it is here is RF4 representing a 4-volt input, and ref green representing a 3-volt input. We have LEDs, blue, red, and green, and resistors to protect the LEDs from burning out. Now I will talk about the blue channel, U1. Here you can see it. It is a low-end detector. Its configuration is a difference amplifier. This stage compares the input both in against the 4-volt voltage. It is configured to have a negative slope, as you can see here. At 0-volt input, our input is high and the blue LED is on. As the input voltage increases, the output voltage drops, and at around 6-volt input, the output is 0 volt and the blue LED turns off. Here you can see the red channel U2. It's a high-end detector. Its configuration is a non-inverting amplifier and it has an offset. This stage monitors the input both in. It creates a positive slope. Here you can see it, but with an offset, so it doesn't turn on immediately. At 0 volts to 6 volts, the calculated output is negative, so the red LED is off. Around 6-volt input, the red LED starts to turn on, and at around 12-volt input, the output is high, so the red is fully on.
Hello everyone, my name is Şevket Kadir Karakaş, and I'm going to talk about the green circuit, and then I will demonstrate our milestone implementation. Here you can see our circuit. The main difference for the green circuit is that it doesn't get its input from directly from potentiometer. Instead, it gets its input from output of the blue and the red circuits. Its operation is inverting summing amplifier. It inverts the inputs of outputs of the red and blue one, and it gives us green output at the middle range around 6 volt. Here you can see we have a reference voltage for green circuit. It is around 3 volt, and it gets its input from output of the blue one and output of the red one. And it when the blue is high, green is off. It gets blue gets lower, and then green gets higher, and it peaks, and then the red one gets higher, and again the green one fades out, and it completes its cycle. It's only active in the middle range. It's That's its operation. We can have green output at the middle range. Now I can demonstrate our milestone working principle. Here is a video. At the beginning, we have blue output, as we mentioned, and as blue fades out, the green outputs gets in. You can see a color between blue and the green one. We have full green. As the green fades out, the red one get turns on. We have a color between red and green one, and it completes its cycle. And it's here our circuit configuration. And that is all we can say. Thank you for listening.